So the first section is understanding what a relationship is, and then if it's a function, and then the parts of a function, the domain and range. So you have to be able to do, we're going to do one of each, from a graph, from ordered pairs or a table, and from mapping. You're going to have to determine those three things, meaning will it be a relation, will the relationship be a function, will the relationship be a function, and then the parts to the function are the domain and range. Domain is your x values, and the range is the y values. So number one is example from a graph. Okay, so if you're given a graph, then you have to scan the graph for domain. You have to go left to right. This is when I put the L and the R. We did this on a white foldable. It's over there. So if I'm scanning, this is the actual function here. Is this upside down kind of V. This is the left of the graph. This is the right. But for domain, since domain is your x values, guys, you have to look up on the x-axis. So over here, this is pointing to a negative infinity. Sorry. And positive infinity. But that's left to right. So I'm scanning basically from this left to this right. Okay. Well, I know you were saying negative infinity to positive infinity, and that is true. And the inequality, I would start from the least to the greatest. So it would be a negative infinity is less than x, which is less than positive infinity. But we have to know what it means when we get this inequality as a solution. Huh? It says it on the top of the paper. Back to this. What does a negative infinity to a positive infinity mean? Yep, it means all real numbers. You can just use a symbol if you want to, the double R. So please make sure you pick the right answer choice whenever you come up with this type of inequality. Now, your range, since it's your y values, we have to go from the bottom to the top of the graph. The bottom of the graph, there's two bottoms right here, but they're both pointing down. If I look at the y values right here, pointing down would be to a negative infinity. The top of the graph is here at 3, 0, but I have to look at the y value, and since it's a solid line, it's closed dot at 0.
So it's a negative infinity is less than x, which is less than 0. I mean, less than y.
Negative infinity, no, You go from this, I'm pointing to all the y values here. So we have to know what this type of values these are. Y'all are saying this one incorrect. But y'all stop. So is 5 part of the range in this? Is the number 5 in the range for this graph? Is the number negative 10 in the range?
Yes.
Yes. Okay. Is the number negative 0.5 in the range?
Yes.
Is 0 in the range? Okay. Is 0.5 in the range? Okay, so what numbers are we really talking about here?
0 and below.
So how would I write that? You're right, 0 and below.
0.
No, what values are the range again? Y. So how would I show values 0 and below? Y is less than or equal to 0.
That makes sense.
All right, now determine if this is a function. On the graph, for a graph, You have to use the vertical line test. Basically, I'm just writing vertical line test. And this was on your white set of notes, foldable. It was right after we did the blue, discrete and continuous. So basically, you just draw a vertical line anywhere on the graph. Please pay attention. And you check that that vertical line only touches once. If it touches only once, it is a function. If it touches more than once, it's not a function. So is this a function?
Yes.
Yes.
Okay, it is a yes.
Oh.
So how do you determine off of a graph if it's a function or not?
If it touches the line twice. The vertical.
If the vertical line touches it twice or more,
Oh, no.
then what would that indicate?
Not a function.
Not a function. It has to touch at only one time for it to be a function. Okay, so number 2, guys, is an example of mapping. So your first circle here is your x values. It says right there x. And then the second set here is your y values. So our domain members are x. This is when we use a little bracket and we list the values of the domain.
0, 4, 9.
Yep, 0, 4, 9. Done. Now we do our values for our range.
2, 3, 4, 5.
Yep,
2, 3, 4, 5.
2, 3, 4, and 5. Yes. Now we have to look at the mapping to determine if it's a function or not. With the mapping is your arrows.
Oh. It touches twice, yeah. It goes to a 4 and a 5.
Yep, right here where this 9 splits,
It's not.
because it's 9, 4 and 9, 5, this is not a function.
No.
Just no. Okay, remember the x's can't repeat. All right, so here's another graph. Let you try it. Remember, domain, we're scanning left to right. Find the left of the graph, but look and find where it is on the x-axis. Find the right of the graph and look and find where it is on the x-axis. Who thinks they have the inequality for domain? All right, Abdul.
-2 is less than x, which is less than 2.
Yes, but it's less than and equal to,
Less than-
because our line is solid. There's no open circles. Okay, now our range. This is when we scan from bottom to top.
0 to 4.
Yep. Here's our bottom right here at 0. Here's the top at 4. So 0 is less than or equal to y, which is less than or equal to 4. Would this be a function? No, it is not a function, because when I draw a vertical line, it touches at 2 spots. Do we understand how to determine that? Okay, so here's what I'm going to ask you to do. Number 5, try this test-like question. Which statement is true of the 2 graphs? You have to compare them and see if you can pick the correct answer choice. Read them, apply them. Since you have graphs, we should be testing our vertical line theory. The answer here is D, guys. Neither graph is a function. Graph A does not pass the vertical line test. It touches at 3 different spots.
And graph B.
It's vertical, so it touches at every spot. So yes. All right. Go to the next page. You're going to end up doing 4. I want to do each style. Okay. So we did a graphing. We did a mapping. Number 6 is an example of ordered pairs or a table. Order pairs and tables go together because they're listing your x and y values. So looking at the function, and we have the set of order pairs here. Remember, your order pairs are your x comma y. If domain are the x's, then what's our answer? 10, -2, 5, 4. Yes, they don't have to be in order from least to greatest, but you have to have all the x values. The x's are the first coordinates in the order pair. Range is your y. That represents the second coordinate.
7, 4, 3, 10.
Yep, there's our range. Now, the second or the third part here, it didn't ask if it's a function or not, but is this a function?
Yes.
Yes. Do any of the x's repeat?
No.
Okay, so it's a function. What they want to know is what's the value of the function for f of 10? Yes, very good. See the I right there? There's the x is 10. So the answer is 7. You just get it off the list of values. Okay?
With the sign.
All right. So let's talk about when we have open circles. So I'm going to number 8 here. All right. Domain is scanning from left to right. Here's the left of the graph of this wave right here. It's open circle, so that means it's open here at the -2. Where's the right of the graph?
-2.
No, that's the left.
Oh.
Where would the right go to?
2.
Yeah. You go up, it's the open circle at 2. So your range are the values from this -2, not including that -2, to that +2. How would I write this inequality to represent the domain?
-2 is less than x, which is less than 2.
Yeah, we don't have the equal to sign, no line underneath. All right, range. We look at the bottom to the top. Here's the bottom of the graph right here, and it's a solid line, so it's this point, -4.
And the top of the graph is 1.
No, it is 0.
Oh.
So we go from -4 is less than or equal to y,
Which is
less than or equal to 0. Yes. Would this graph be a function?
Yes.
The answer is yes. Okay. Because no matter where I touch, no matter where I draw a vertical line,
It's never gonna touch.
it's only going to touch it once. It's not going to touch it twice or more. All right, so let's address the test-like questions. 9 and 10, I want you to do right now, and then 12 and 13. I want everyone to attempt, and let's check your understanding of 9 and 10, and then 12 and 13. You can do the other ones too. Okay, we should have G for 9. We're talking about the range. It's the y. That's the same thing as f of x. 10 is also range, which is y, which means A and C should be eliminated. And the answer was D. Now, on the back, sorry, let me go up.
I only got 1 on the back.
12 and 13. 12 and 13.
Is 12 all real numbers?
No.
Yes, 12 is G, all real numbers. And then domain is F on 13. Okay, so now section 2, rate of change. To do rate of change, there's 3 ways we're going to ask you to do rate of change and slope. They mean the same. Rate of change is slope. Slope is rate of change. So from the table, this is when we do the change in y over change in x. Or you can do y2 minus y1 over x2 minus x1. This is the easier and most accurate of the 2 options. This is the method I would prefer you using to make sure we get it right. So In order to do it off the table, guys, you have to pick 2 points in the table. Which 2 points do you want to use?
3 and 10.
Okay, circle 3 and 3 and 30.
3 and 30. Yeah.
Sorry, and what other point?
7 and 70.
Okay, 7 and 70. Okay, now we're gonna use the formula. How would I set this up?
7 minus 30 over 7 minus 3.
70 minus 30
70 minus 30.
over 7 minus 3. Okay, do that and let's get our answer. Stop talking and focus and do this. What is going on?
10.
Yep, we should get 10. You could just put this in the calculator. You go alpha equals 70 minus 30, 7 minus 3. Yes, not right now. You have to wait. Okay. Where's the... Oh, there it is. Okay. Number 15, start. I need you to pay attention to this and understand why you should use the slope formula. So, first thing is, they tell us right here, rate of change, that's the same as slope. Stop talking while I'm instructing, please. Thank you. Okay. For this type of problem with the graph, you should be either counting rise over run or using slope formula. The issue with this problem is, do y'all see our negative 3.6 point right here is not an exact point. It's a decimal. So when it's a decimal, we cannot do rise over run. Because when I count down, that's not 1 unit. That's part of a unit. So you would need to do this first. Using, oops, sorry. Negative 3 as your x1 and 3.6 as your y1. 5 as your x2 and 2 as your y2. So let's try to use the formula right now and let's see if you get the answer. Hopefully we have 2 minus the 3.6 on the top of our ratio and 5 minus a negative 3. I believe it's the decimal answer. Yeah, negative 0.2. Yes, good. Good. All right, and then if you ever are given 2 points, you always use the slope formula. All right, let's try in attempt number 16, guys. Number 16. What is going on? What'd you say? Yeah, negative 2 is right. What is going on? Okay, so those are the 3 ways I'm going to ask you to find the slope. Go to the next page. All right. You are going to do the next example, 7, 18, and 19. We are going to go to graphing. So go to number 20. Why is there no internet? Those connectors. Okay, so we are either using our rise over run, using exact point. So I can see there's an exact point here on the y-intercept of 2, and then here's the other exact point at 2, negative 3. I'm just going to label this A and B. Okay, so if we're counting the rise over run, you have to start on the first point reading left to right. So start on the A here at the 2. And a couple things, guys, when you're doing this, like looking at the graph right off the bat, What type of slope is this? Yeah, it's a negative. So yes, you're going down
-5.
5. So that's -5, and then you're making a right
So
2
it's
times.
-5/2. That's the answer.
Yep. Comes out to be -5/2. Yes.
Easy, lemon squeezer.
Now I tend to draw this little triangle to help see each slope.
And then the other one is 0, and then the 22 is 0.
Yes, because on 21, the line is this horizontal line, and all horizontal lines have a slope of 0.
Okay, so we're on number 3 now.
Here, 22 is this vertical line,
So
and what would be the slope of all vertical lines? Yep, you can just put UND. So just remember your acronym here, OIVUX, to help you. H for horizontal, 0 slope, Y equals the number. You're going to have to do the equations of this as well. V is for vertical, undefined slope, X equals the number. So let's see if we remember what to do for 2 points. How would I set up 23? How would you write it before you type it?
Oh. -1 is over -3 minus -12.
Yes. All right, let's go to our calculator and let's see if we can get this slope. It's a -1/3. That's what you should get if you put it in the calculator. Okay, let's try 24. How would you set up, sorry. How are we going to set up 24?
-2 minus 7 is over -11 minus -11.
Yeah, it is. No, it's undefined. Yeah. If you get an error or divide by 0 error, it's undefined. All right, the last thing we're going to ask you to be able to show proficiency in is understanding slope-intercept form. But I also wrote standard form because sometimes the equation is given in standard form. The one you need to know is slope-intercept form right here. That's when it looks like y equals mx plus b. I'm circling the m because that represents the slope. You should always get the y isolated and circle what's in front of the x. Not yet. B is the y-intercept. So if it is in standard form, which is ax plus by equals c, please add this note. Change to y equals mx plus b. I need to fix that. That should be mx plus b. Change to the slope-intercept form by first moving the x, doing the opposite, and then divide by y. We're going to have to understand these steps on the second page. The first one is just really, can we find the parts to write the equation? Or if they give us the equation, can we pull out the parts? So 25 says, write a linear equation with a slope of 1 and a y-intercept of -7. That means, please do this, the m is going to equal what? 1. And the y-intercept represents what part? So your b equals -7.
So
we're just
minus b, y equals x minus
y equals x minus 7. Or if you wanted to write 1x minus 7, that's fine, but this is how it would be written on a test. They don't show the invisible one. So on 26, they want you to identify the slope, which is your m, and your y-intercept, which is your b, from this equation, y equals -3x. So what represents the m?
-3.
Yep, very good.
And b is just 0.
There is, yeah. We don't see a plus or minus to b, so it doesn't exist, so it's 0. Okay. All right, so star, go to the next page, and star or circle 27 and 28. Because now we're going to have to put it in the correct form so we can get the parts. So again, identify the slope and the y-intercept from the equation 5y equals 2x plus 20. Is this equation in the y equals form?
No.
No. What's with it right now? What's wrong with it?
5y.
Yeah, the 5 in front of the y. So first we need to eliminate that, which is divide everything by 5.
You'll get negative, just 2 over 5.
Yeah, so the 5 coefficient cancels. Y equals, yes, 2 over 5x, then plus 4. Okay, good.
That's how you solve?
Yeah, that's how you solve for y. And this one right here. So now I can physically see what number represents the slope. What's our m? Yeah, 2 over 5. And what's the b, the y-intercept?
4. Yeah.
There it is, 4. And now we're done.
This is not that hard.
Now, 28, identify the slope and y-intercept with the equation x plus y equals 5. It's not solving for y. We have to make it solve for y. So what would we need to do to isolate the y variable?
Minus x.
Put minus x on your paper. Good. That x term cancels on the left right here. Now my y is by itself, and we're going to write
Y equals 5 minus x. I mean x minus negative x.
negative x plus 5. You want to put your variable first, then the constant last. Okay, so looking at this equation,
M is negative x.
oh, so close.
5.
Yeah, the invisible one. M is the negative 1. And what's the b?
5.
Yeah, b is 5. Okay. So I'm either going to ask you to give me the slope and the y-intercept from the equation, or I give you the slope and y-intercept and you give me the equation, or I'm most likely also going to ask you to do it given a graph. So here are our steps. If you're given a graph, first find the b, which is the y-intercept. That's where the line crosses the y-axis. So if I'm looking at this graph here, I can physically see right there.
3.
Yes, our b happens at a negative 3. So b equals negative 3. Step 2 says find the slope, the m, using rise over run. So if this is one point, here's the other point on the graph. Now I count my rise over run.
7. Over 2.
Yeah, so 7 over 2.
Equals.
Now we write the equation. So y equals 7 over 2x minus 3.
Oh yeah.
Okay. So on 30, same premise. Find your b first, then find your m.
3.
What is 3?
B.
Yep, b is 3. Just looking at the graph, what type of slope should this be?
Negative.
Yes.
Down 4 and then to the right 4.
Okay.
Wait, no, to the right. Yeah, 4. So it's negative 4 over 4.
Which, yeah, if you simplify negative 4 over 4, it is negative 1. Okay, so our equation,
Y equals x.
negative x.
Plus.
Yep, good. All right. Now, 31. Well, that's the slope. I want the equation.
Y equals x minus 3.
So close.
Y equals.
Y equals just negative 3.
Because you don't do the thing.
Because we have the slope is 0, so we're not going to have a number in front of x. All right, what about 32?
Y equals negative 1.
No, it's not y.
Oh, x.
Negative x.
X equals negative 1. Guys, y'all got to remember, if it's a horizontal line, it's y equals a number. If it's a vertical line, it's x equals a number.
1/5 x plus 2.
All right, so let's see if you can get the multiple choice type question. Based on the slope alone, because it's a negative 1/5, what should we eliminate? A and C. You're right. Because those are both positive. They both B and D both have a y-intercept of 2, so we're trying to find the slope of negative 1/5. The answer is B. Okay, so finish the ones we didn't do, and then there's an extra credit on quizzes. I need to make sure it gets turned on. That's what you should use to study, guys, and along with your spiral.